Hello friends, I'm Vinod Prabhu and welcome to 7 Sense Aptitude Prep. In this video on calendars, we are going to look at how we can arrive at the answer on a particular day for a date that is given using shortcuts. So in the first 5 videos, we started off with the basics. We looked at what calendars are, we looked at what odd days are, we looked at odd days in an ordinary year, we looked at odd days in a leap year, and in the fifth video, we look at questions of the format on what days are Wednesdays in the month of April 1956. Such formats we've already looked at. So for the same questions, we'll see whether we can approach it using shortcuts. So we have two methods. I am going to show you both these methods. You look at and understand both the methods and ultimately choose one. And when you choose that method, use that in all the problems henceforth. Do not alternate from one to the other because there are codes, there are numbers that would be confusing. You use either the long method that we've used until now or the shortcut that I'm going to show you in this video. Look at both, see what you're comfortable with and use only that method from now on. Okay. So shortcuts using codes, the negative of this method is that there are some exceptions that you also have to keep in mind. I'll show you what the exceptions are. If you do not remember the exceptions or you miss including that, the answer would definitely be wrong. So let us look at a typical example. Okay, so firstly, we need to see what the year codes are. So year codes are codes given to a set of 100 years. From 1600 to 1699, the year code is 6. So you remember the year code. We look at what the day codes are, we look at what the month codes are, we look at what the year codes are. The day code for the odd days is the same as the previous method, where 0 is Sunday, 1 is Monday, so on until Saturday is 6. So that is the day code. We look at what the year code is. So 1600 to 1699, if you are asked a date between these 2 years, 1600 and 1699, the year code is 6. If it is between 1700 and 1799, it is 4. Between 1800 and 1899, it is 2. Between 1900 and 1999 is 0. So you remember this, 1600 to 1699 is 6. Then the pattern follows as 6, 4, 2, 0. So 1700 and 1799 is 4, 1800 and 1899 is 2, 1900 to 1999 is 0. Then this pattern repeats. 2000 to 2099 is the same as what you saw for 1600 to 1699. It again becomes 6 and so on. So for all of these years, it's the same year code. 1600 to 1699, whether it is 1601 or 1653 or 1685, the year code is 6. So this is something that you absolutely have to remember if you're using the shortcut method, the year code 6420, 6420, and it repeats. The month code. Okay, so there is also something known as the month code, where each month gets a code. We will see how that code comes into use during our calculations. Our month code, there's a simple way to remember. So the month code from Jan, okay, so Jan, Feb, March, April, May, June, July, August, September, October, November, December. Okay, the year code is 03, the month code is 033614625035. Okay, so the corresponding number in front of the month is the code of that month. How do I remember this? Seems very lengthy and confusing. So the way to remember this is group this in terms of 3. Okay, so this is one, this is another group, this is the third group, and this is the fourth group. The first group and the last group, you remember it as 033 and 035. Okay, there's a difference of 2, 033, 035, and the two groups in between, they are 614 and 625. So remember, first group is 033, the last group is 035, and the two groups in between 614 and 625. So these are the month codes. So we've seen the year codes, we've seen the month code, the day codes remain the same. Okay, the same code that I've written here. The day code remains the same. Sunday would be 0, Monday would be 1, and so on. Remember these codes. You cannot forget these codes and expect to solve the problems using shortcuts. Okay, so you absolutely need to remember each of these problems that we are going to solve would use these codes, and we would look at getting the answers. So we have a typical question here. What was the day on 28 Jan 19 54. So 28 Jan 1954. What do? You first take the last two digits of the year. Okay, the last two digits of 1954 are 54. So take this. We are going to add some numbers. So take this. So that is 54. Now divide this. 54 is to be taken. Okay, keep it separate. Now divide 54 by 4. In the previous method, we used to worry about the remainder for the odd days, right? So now, but here we look at the question. 54 by 4. 4 into 13 is 52. Okay. So then there is a remainder. So now here we are not worried about the remainder. We are worried about the quotient. So 54 divided by 4. 4 13s is 52. So we take 13. We take the quotient, not the remainder. I repeat. So you take the last two digits of the year, which is 54. You divide by 4 and then take the quotient. So the second number that you have to keep in mind is 54. Then our second number is 13. You take the date as it is, 28 Jan. So you take 28. Now, what is the code for 1954? The code for 1954 is between 1900 and 1999. We had the year code as 0. Correct? So in the previous slide, we had the year code as 0. So you take the year code as 0 for 1954. And then what is the code for the month? The code for Jan is also 0. Okay, so you take the date as it is, then you have the month code is 0, you have the year code as 0, and now you add these numbers, 54 plus 13 plus 28. When you add these numbers, 54 plus 13 plus 28, you get 95. And 95 you divide by 7. Okay, so 95 divided by 7, you will get 4 as the remainder, and 4 according to our day code corresponds to Thursday. So I repeat, you take the last two digits of the year, you keep that here, 54. Now divide 54 by 4 and take the quotient. We got 13. Now take the day, as in the day, 28 as it is. For Jan, add the month code, and for the year 1954, it is between 1900 and 1999, you take the year code, and then you add this, you get 95. Then divide by 7. Your remainder, 7 13s is 91, remainder is 4. So 4 corresponds to Thursday. We will solve problems using this. So, and the only key thing to remember here is practice. If you practice, you would not even take 15 seconds to solve such questions. It would be very, very easy. Now we look at one exception. See, one of the plus points of shortcuts is its speed, but one of the negatives is that there are some exceptions that have to be kept in mind. So day of 11th Feb 1684. Here there is an exception, as in this exception to the rule that we have to remember. If the month is Jan or Feb, repeat, this is very, very important. If the month is Jan or Feb and the year is a leap year, then you subtract 1 from the total sum and take the remainder. Okay. Here 54 is not leap, right? 54 by 4, it's not a leap year, so that exception doesn't come into play in this question. No exception. Here 84 by 4 is 21 with no remainder, so it is a leap year. What do you do? If the date asked is only in Jan and Feb, so if it is after that in the remaining 10 months, it's okay. But if the date is in Jan or Feb, you subtract 1 from the total. Like we've gotten the total here 95, similar total that you get here, you subtract 1 and then divide by 7 and find the odd day. So how do we do this? Firstly, you take the last two digits of the year. So we do 84, we keep it here. Then you divide 84 by 4. 84 by 4 is 21, right? So take the quotient. Then we add 21. Then you add the date, which is 11. You add the month code. Month code of Feb is 033. So I'll repeat, I'll write that here. 033, 035, 614, 625. So this is Feb. So we add 3. And this is between 1600 and 1699. So the year code for that is 6. We add 10, 15, 125. But this is a leap year and the date asked is in Jan or Feb, right? It's in Feb. So you subtract 1. So you get 124 divided by 7, 7, 54, 54. That you get is 49 with a remainder of 5. The remainder of 5 is a Friday. So this day of 11th Feb 1684 is a Friday. I repeat, take the last two digits of the year, which is 84. Then you divide it by 4 and take the quotient, which is 21. Then you add the date, which is 11. Then you add the month code for Feb, which is 3. Then you add the year code for 1684, which is 6. Then you get 125. You subtract 1 from it. You get 5 as a remainder. 5 is Friday. Okay, that is all there is to the shortcut method. If you're comfortable with this, please use this. If you're comfortable with the earlier methods, which we have shown in the playlist, please use that as well. Okay, let us look at a few examples. Before we look at examples, let us write the month code and the year code for our reference. Okay, the month code, as we have discussed, is written like this: 033, 035, 614 and 625. Okay, so you know this is Jan, this is December, and the month code are 1600. So 1699 is 6, and 1700, 1799 is 4, 1800 to 1899 is 2, 1900 to 1999 is 0, and then 2000 to 2099 is again 6. Okay, now we have that. Let us solve the problem. What is the day on 10th July 2078? First, check whether it's an exception case. What is the exception case? You see whether it's a leap year. 78 by 4 leaves some remainder. So 4 19s are 76 with a remainder of 2. So it is not a leap year. So there is no exception. First you add the last two digits of the year, 78. Then you add the quotient that you get when you divide it by 4, which is 19. Then you add the date, which is 10. Then you add the month code. So you know this is July. Okay, so July is 6. And then you take the year code, which is this. So you add 6 again. Okay, so adding the first steps, what do we get? 78 plus 19, 97, 107, 119. We get 119. 119 when you divide by 7, we get 0 as the remainder. Okay, 17 sevens is 119. We get 0 as the remainder, and 0 as we know corresponds to Sunday. So the day on 10th July 2078 is a Sunday. Quickly, we will solve another question. Check whether this is an exception. 1856, 56 divided by 4. Okay, so 54 is a leap year. 14 is a leap year, so it's an exception. Date as is in Feb, so it is an exception. We have to subtract 1. Remember, subtract 1, subtract 1, subtract 1 here. So firstly, take the last two digits of the year, which is 56. You divide by 4. 56 by 4 is 14. You write the quotient. Don't write the remainder here. It's the quotient. You take the date, which is 1st Feb. 1. For Feb, what is the year code? We have this is the year code, which is 3. And for the so Feb as the month code, sorry, we have 3. And for the year 1856, we have the year code as 2. And add this. 56 plus 14 is 70, 75 is 76. We add, we get 76, but it's an exception case. So we subtract 1. 76 minus 1, 75. Okay, that is why we get 75. 75 divided by 7 leaves 5 as the remainder. And if it is 5 as the remainder, it corresponds to Friday. This year it's a Friday. So we look at the next question and we repeat the month codes here for a reference: 033, 035, 614 and 625. Okay. So for November 1983, what are the Mondays? So we've seen those questions, right? On what dates do the Wednesdays of a month lie? So we try to see what is 1st November of 1983. Okay. When we see what is 1st November, we get the day, and then we see what the Mondays of that particular month are if 1st of that month falls on some day. So to find out 1st November 1983, first we add the last two digits, 83. Then you have 83 divided by 4 is 20 with the remainder of 3. So you add 20 here. Then you take the date 1. Then you add the month code. November's month code is 3, and 1983 the year code is 0. So you have 47107. 107 divided by 7 is 137 with the remainder of 2. 2 remainder is an odd day. So you know Sunday is 0, Monday is 1, Tuesday is 2. So 1st November is a Tuesday. What have they asked? What are the Mondays? If 1st is a Tuesday, 8th is also a Tuesday, which means 7th is a Monday. 7th November is a Monday, so we have 14th as Monday, 21st as Monday, and 28th as Monday of this month. November 1983. Okay, recap. Last two digits of the year is 83. Divide by 4 and take the quotient is 20. Then take the date is 1. So this is what we've written here. Then you add the month code, which is 3, and then the year code, which is 0. You get 107. 107 divided by 7. We get the remainder as 2. And 2 corresponds to Tuesday, which is 1st November. Now you get the Monday. You then see what the next Monday, next Tuesday is, which is 8. One day before that is 7. Okay. So we looked at two different methods, right? The conventional method, we've seen what the odd days are. We've seen how to take it for leap years and ordinary years. We've seen how to split the years until now. And in this video, we looked at the shortcuts. The exception that you have to remember is that if it's a leap year and the date asked is in Jan or Feb, we subtract 1 from the total. You take the last 2 digits of the year, then you divide by 4 and take the quotient, then you take the date, then you add the month code, then you add the year code. 5 things that you have to add. You take the last 2 digits of the year, the quotient on dividing the last 2 digits by 4, then you add the date, then you add the month code, then you add the year code. Whatever you get, you divide by 7. Whatever is the remainder corresponds to that particular odd day. So if you have liked this very simple approach to calendars, I would request you to click on the thumbs up sign and subscribe to our channel, because we are going to provide such high quality videos that are simple and easy to understand and guarantee accuracy and speed in the examination. We would request you to share it with your friends, people who haven't heard of us. We would like you to also click on the bell icon so that you do not miss out on any videos that we upload. And for more practice on these modules, practice on company specific tests, we request you to visit our website 7senstalent.com, sign up and log in there if you haven't. We'll have some free courses and there are some paid courses as well. Please see what are your requirements, and you can ensure that in this tough economic environment you get the dream job that you want. So thank you so much for spending your time. This is the 6th video on calendars. There's just one more video in this playlist that I'm going to record next. That would be on some key points that we are going to keep in mind when we solve calendars. Thank you and have an awesome day. Bye.